Elon Musk's Grok AI to be used by US government at a price of 42 cents per agency. Trump admin joining Meta, OpenAI in recent trend of the AI government contract. The chatbot will be one of several available to workers in any opting federal agency. Grok's XAI's flagship chatbot has become official sanctions part of the United States government operations. XAI in the United States linked till Wednesday that guarantees the use of the Grok across the federal government to $0.42 per agency, per the government press release. The newly kindly skinned Grok of government based on Grok 4 and Grok 4 Fast models is available for all federal agencies effective immediately. The deal lasts for 18 months, terminating in March 2027, and is the longest AI contract yet signed by the government. Elon Musk's XAI also offers step-up models focused on a higher security classification for unknown dollar amount of the per agency base. At all levels of the access to the Grok for government, XAI has pledged a dedicated engineering team and agency training program to support the government Grok and encourage its most efficient use at all time. Grok joins Meta, OpenAI, Google, and Anthropic in the list of major AI companies that have been contracted by the U.S. government in the last week. The Governmental Services Administration (GSA) has been moving quickly each on one-go initiatives and based on securing a wide field of the AI agent chatbot and the tools for government workers to boost productivity and efficiency. Widespread access to advanced AI models is essential to build the efficient counter the government to the taxpayers deserved, said Federal Acquisition Service Commission's Josh Greenbaum in the GSA press release, or rather new one Gov LLM deals were signed for an incredible low price tags, and Meta undercutting the bunch of the $0 deal with the US government. The partnership with Grok may come as a surprise for valid reason. The Elon Musk, the personality and the CEO behind XAI, had a very well documented and highly contentious falling out with President Donald Trump. The pair began the year as a fierce political alliance, with Musk heading up the Trump's Dodge office for governmental cuts, including those that effectively killed the Biden-era Chips and Science Act. But the relationship fractures as Musk steps down from the government, resulting in a public fallout on social media. That XAI is signing deals with the US government under the watch of both Trump and Musk signals to some that the rift between the two may be mending. Musk has begun to walk back in his more abrasive takes on the president in recent months, and the pair has been seen together in public. GA's acquisition of Grok has, as an option for federal workers, has attracted its own share of controversy. Civil rights groups signed petitions requesting the Trump administration bar Grok from government, citing the occasional ideological ban of the Grok's responses as violation of the Trump-owned AI action plan. The plan requires the AI used by the government to be neutral and no-partition tools that do not manipulate the responses in favor of the ideological dogmas. Grok's ex-count famously began calling itself Mecha Hitler for a few days in July, accompanied by the slew of other posts praising the German Nazi Party during the World War II. and calling for anti-Semitic action. XAI has since addressed these responses and assures users they will not happen again. Next one is Intel taps Apple's for potential investment, says a report. Companies said to be discussing ways to work together more closely. Half a decade after the end of the Intel Mac, the Intel is in the preliminary discussions with Apple regarding a potential investment, according to the Bloomberg, which cites sources familiar with the matter. And the two companies are also reportedly exploring ways to work more closely together, although it remains to be seen whether many potential deals can be reached as negotiations are in the early stages and may not come to fruition. Reported talks with Apple follows a string of recent deals, including major funding from NVIDIA and SoftBank and the conversion of a CHIPS Act funding from the US government to equity. These moves are believed to be part of the company's revival strategy that not only includes securing money, but also securing commitment to use the company's products and service going forward, justifying developing Intel's next generation 14A process technology and building production capacities that will support that node. Apple used Intel CPUs inside each pieces from 2005 and 2020, and it never used the company's low-power processors for its iPhone and iPad. Instead, it switched its Macs to ARM-based SoCs in 2020. Apple's current computers do not use any hardware from Intel, even though these systems use technology originally developed by Intel or co-developed with Intel, including DisplayPort, NVMe, PCIe, Thunderbolt, and USB. Even Thunderbolt 5 controller and retimers found in the latest MacBook Pro come from Apple, yet are certified by Intel. It is unknown how Apple and Intel could collaborate going forward, though the high-tech world is very convoluted. Intel's timing is enter negotiations with Apple seems favorable as the high-tech giant has just received investment from NVIDIA, SoftBank, and the US government. Such a high-profile backers reflect a growing belief in Intel's comeback, so it should be easier for the company to persuade Apple and other potential investors to buy Intel stock. Also, Apple has prioritized expanding its investment within the US, even though much of its supply chain remains abroad. In August, it pledged $600 billion toward domestic initiatives, an increase from a previous $500 billion commitment. Obviously, a deal with Apple would further underscore confidence in its direction, which would carry symbolic weight of bolstering Intel's public image. However, if the rumored deal does not yield any agreement, this might harm Intel's position. The next article is the TSMC unveil AI designed chips to cut the energy use. The chip design firms are increasingly relying on AI-powered software from providers as Cadence and Synopsys. The computing chip that power artificial intelligence consumed a lot of electricity. On Wednesday, the world's biggest manufacturer of those chips showed off a new strategy to make them more energy efficient, using AI-powered software to design them. At a conference in Silicon Valley, Taiwan Semiconductor Manufacturing Company (TSMC), the contract manufacturer that fabricated chips for NVIDIA, showed off a range of ways that it was hoping to boost the energy efficiency of AI computing chips by about 10 times. NVIDIA current flagship AI servers for example, can consume as much as 1,200 watts during demanding tasks, which would be the equivalent of the power used by 1,000 US homes if run continuously. The gains TSMC is hoping to achieve come from a new generation of chip designs in which multiple chiplets, smaller pieces of full computing chips, using different technologies are packaged together to make one computing package. But to make use of those technology, the firms that chips are increasingly relying on AI-powered software from providers such as Cadence Design Systems and Synopsys, both of which rolled out a new product on Wednesday that had been developed in close coordination with TSMC. For some of the complex tasks in designing chips, the tools from TSMC software partners found better solutions than TSMC's own human engineers, and did so much faster. And now we have another article. Tenstorrent to productize RISC-V CPU and AI IP. AI chip startup Tenstorrent has begun productize its RISC-V CPU and AI cores as licensable IP. Tenstorrent already has IP licenses, including LG and Hyundai, with most of the companies booking to date coming from IP deals. Aniket Saha, Vice President of Product Strategy at Tenstorrent, told EE Times, "We are the only company I know of that uses its own IP product in its own chips," Saha said. Contrary to the widely held industry belief in offering both silicon and its IP would create a conflict, this hasn't been a problem for customers so far, in part because they are either customizing the IP or addressing the different markets, specifically an automotive, Saha said. "I've been pleasantly surprised that customers actually want the IP we are using in our own product because we are betting our company on the IP," he said. "That's been excellent for IP we are building." Tenstorrent will also license IP to companies planning to build silicon products that compete with its own workstation and data center hardware product, Saha confirmed. "Customers will often building things slightly different," he said. "They can build a complementary product even if they are in the same market. One emerging customer is planning is to do just this, build something very similar to the Tenstorrent hardware, but with different memory configurations and other design choices," Saha said. "Even in the data center space, where our main business is, you could build ancillary projects that not compete with us because of different core counts and configuration. So we are not seeing that much conflict," he said. "Even if there is some conflict, we'd get loyalties in the back end. We'd rather win loyalties in the back end than not win anything at all." Sa said his armed primary competition for Tenstorrent IP product, largely because they are the incumbent versus other RISC-V IP vendors like Andes. "We welcome more high-end CPU IP vendors because that that make the RISC-V story stronger. He said, For RISC-V and us to succeed, we need credible high-end CPU IP companies. Competition also comes from ground-up in-house design, Sa said, but mainly from mid-range cores or very specific implementations. Differentiations for Tenstorrent IP projects in general include the company's commitment to open sourcing as much as possible and its willingness to let its cores be customized. IP companies don't typically allow the modification beyond the configuration options because it makes the IP very difficult to support. We saw, starting with the sovereign computer market, a strong pull coming in for using the IP and being able to take full control, Sa said. If our customers want to modify the IP, we provide them an entire codebase, the infrastructure that is required to modify, they build on the top of that. We call it the innovation license, and this has quite a lot of company cup right now. In general, however, customers will be steered away from the customization depending on the internal engineering sources available at any given time, Sa said. Because it's early days, we've upset some customers who wanted us to make a modification to the IP. Sa said, but also will we phase out doing the direct customization or heavy customization. Whenever there is a heavy customization, we are hoping the customer will pick it up. A lot of traction of the IP product is coming from Asia, particularly China, with us interest slow for so far, Sa said. Ascalon CPU cores. The first generation of the Tensor RISC-V CPU, Ascalon, will have its IP prototypes its implementation between 10 to 20 spec in 2006 per gigahertz, reached states are largest and the third largest and the largest Ascalon X will compete with the ARM Neoverse version 2 and version 3 scores, Sa said. The third largest Ascalon S competes roughly with the ARM Cortex A78. Verified validated subsystem with configurable clusters between 2 and 8 Ascalon cores will be also available. Ascalon interface is specified to be drop-in placement and arms, covers both the coherent and non-coherent interfaces. Tenstorrent Ascalon cores can be implemented in cluster up to 8 cores. Tenstorrent is moving on an 18-month cadence with the generation of these cores, and with the next generation, Babylon, set to improve the performance, frequency, and PPA. An automotive version of the CPU, Alexandria, has the feature set for automotive functional safety. This also opens up markets like industrial and medical. Because industrial and medical volumes are typically low, ARM traditionally does not go after those sockets, Saha said. We see ways to aggregate some of that volume. A development board, Atlantis, will feature an 8-core Ascalon X CPU with a 50-watt TDP. This developed board will be used by the OEMs. Automotive tier is for tier ones, and ISVs to begin porting software that requires a high single-thread performance. The Atlantis SoC may eventually be prototyped for AI PC, but this is still under discussion, Sa said. 10.6 AI cores, the next generation of the Tenstorrent, 10.6 AI cores, 10.6 Neo, will be released this quarter. Tanuj Aurora, Senior Product Manager for AI at Tenstorrent, told E-Times. In contrast to the current generation 10.6 Blackwell core, Neo has adopted a cluster architecture that shares memory and energy across the cores rather than one per core to enhance the area efficiency and utilization. This is the first time that we knew in advance we wanted to sell this as IP, so we built in a more modular and flexible manner, Aurora said. Tenstorrent 10.6 Neo clusters share memory and energy across 4 cores instead of per core to improve area efficiency and utilization, source Tenstorrent. This flexibility extended to specifying error cache size and data type support, among other things. Similar to the Skylus CPU cores, customers will handle simpler configuration while Tenstorrent will handle customization beyond these parameters. Customers who want to do this in-house can take an innovation license. For innovation license customers, we provided RTL and the verification infrastructure and test benches that we built, and it's on them to do it. Aurora said, but that's a challenging job, so we will handpick those deals carefully. Okay. Next one is NVIDIA's alliance with Intel signaled the end of PC graphics as we know it. It's massive news, and neither AMD nor Qualcomm are ready to compete. If you told me 25 years ago that Intel would end up in decline, that NVIDIA would buy a chunk of the ailing company, and that the two would partner to build chips that integrated Intel x86 CPU cores with NVIDIA's RTX GPU cores, I would have called you crazy, but here we are. NVIDIA has acquired a $5 billion stake in Intel, roughly 5% of the company. For personal computing, we are gonna create a new Intel x86 SoCs that integrate NVIDIA GPU chiplets, fusing the world's best CPU and GPU to redefine the PC experience, NVIDIA CEO Jensen Huang said on the investor call following the announcement. The announcement made headlines, and for good reason. This alliance will create a monster that are Intel and NVIDIA's competitors, namely AMD's Qualcomm. AMD's and Qualcomm will struggle to defeat. A chip alliance that can't be beat. The development of a chip that fuses Intel x86 cores with NVIDIA's RTX graphics will be usually deal for those obvious reasons. NVIDIA's rule the PC graphics with the iron fist but currently lacks an integrated graphics display. That's created a few safe spaces like portable gaming laptops and a gaming handheld like the Steam Deck, where the NVIDIA advantage is irrelevant. It also provides an even playing field between the Intel and AMD CPU in high-end laptops, where said CPUs are paired with NVIDIA's discrete graphics. A laptop maker's choice between an Intel and AMD CPU is mostly about performance and power draw of each, not how tightly the CPU integrates with NVIDIA's GPU. An Intel and NVIDIA chip obliterates that balance. Suddenly, NVIDIA's integrated graphics in portable PCs looks entirely full of server. A tight integration between the Intel x86 cores and NVIDIA's RTX graphics will provide efficiency in SoC design, power draw, and features that the AMD Qualcomm and simply can't match. And it's better in high-end laptops, and the Intel NVIDIA alliance will make it easy for Intel to convince laptop makers that they should pick up Intel. They are all going to use NVIDIA's and GPUs in anyway, so why choose to build a laptop around an AMD SoC with NVIDIA discrete graphic if they could instead build around a competent Intel NVIDIA SoC? Qualcomm is even worse off. The company doesn't offer discrete graphic support at this time, and its integrated graphic solutions are behind the curve. The company was already playing the catch-up in the graphic race, and an Intel NVIDIA chip alliance now moved the finish line several miles further away. Is the start of the new duopoly? The threat of the Intel NVIDIA alliance is so severe that it raises question about how regulators will view them if they are successful at market. As the latest Steam hardware survey shows, NVIDIA's dominance in both laptop and desktop graphics is close to the absolute. I personally find this a bit odd, and I've been putting my money on AMD, and the last few times I needed to change a GPU, but apparently I'm in the minority. As it stands, NVIDIA PC video card market share sits at a massive 74.88%, and NVIDIA's lead is arguably even greater than the figure suggests because most of the non-NVIDIA market share stems from Intel and AMD integrated graphics. AMD's most powerful discrete graphic product, the RX 6600, is the 30th most common GPU in the survey. That puts it behind ancient NVIDIA GPUs like the GTX 1050 Ti and RTX 2060. Intel commands of the CPU market is less absolute, with a roughly 60-40 split in flavor Intel over AMD. The data also showed that the AMD CPU share leans toward the high-end parts with a clock speed of 3 GHz or better, while Intel's CPUs appear to be a mix of low, mid, and high-end options. But the Steam actually skewed the majority in AMD's favor, as the company consumer CPUs are particularly excellent for gaming. Other non-gaming data sources show the AMD's consumer CPU market share is under 25%, and largely due to the laptops and low-end desktops, and while Intel CPUs remain the most common choice. These figures paint green pictures for the competition in the consumer PC arena. On Intel NVIDIA Alliance pairs consumer CPU market leaders with the consumer GPU market leader, and the leaders monster at each of the whatever gains each seen hardware competition recently. Say by industrial graphics age we know it. I suspect each of the alliance held long part anticipated changes in the PC hardware world, and one of the biggest changes was wrought by the Intel NVIDIA GPU will the depth of the discrete graphic as we know it. Here's the issue: discrete graphics kind stock, and a duplicated silicon and including memory that could be more tightly integrated. They make it difficult, even impossible, to pass workloads from a CPU and GPU, forcing these powerful components to function in a silo. They are inefficiency. In an integrated approach with all memory shares across CPU, GPU, and NPU is superior. It cuts down the duplication of memory sources. I didn't expect it is quite long. Today, thank you for your time. See you next time.